Hi everyone, we will show the final project of course 5671, Financial Data Mining and Big Data Analysis. Our project is Real Estate Valuation. My name is Jianyuan Zhang. I'm a second-year graduate, major in computer science and engineering.
Hi guys, my name is Hui Zhang and I'm a second-year graduate and my major is computer science and engineering.
Our final project is Real Estate Valuation. The goal of the project is to predict the housing market using data collected from Xindian Distance, New Taipei City, Taiwan. We have 3 CSV files, which are the features of training set, the labels of training set, the features of test set. And what we need to do is to train some models and use the trained models to predict the labels of test data. By the show function, we can get there are 6 features and 1 label in the training set. There are 6 features. X1 is the transaction data, X2 is the house age, X3 is the distance to the nearest MRT station, and X4, X5, X6, and Y is the house price of unit area. We complete the project by the following 4 steps. First, we load the data from the CSV files, then pre-process this data, and we use some functions to show this data and count the number of data sets. After reading and pre-processing data, we train 4 different models and use these trained models to predict the labels of test data, and finally we write the result to 4 CSV files. Before we can use Spark package, we need import 3 packages and construct a Spark session. We use Spark package to load data from CSV files by choosing header is true. Next, we pre-process data, combine 2 tables into a new table. In order to analyze housing price, we need each house price corresponding to its features. So we can select all features grouped by ID and do the same things to labels. As we have features and labels, we can use join command to join 2 labels into 1 new table. Notice that we need drop 1 ID column since there are 2 duplicate ID columns. Next, we need to transfer the data tab from string to double. Now we have a new table and the tab of all features are string. Because the factor assembler doesn't accept string tab, we need to transfer tab string to tab double. Now we use the following operations to classify all 6 features into features class and classify house price into label class. Given that the test data don't have labels, we only need to classify all 6 features into feature class. Next, we need to split training set to train data and test data. In general, we need to divide the training data into training sets and test sets. The training set is used to train the model, and the test set tests the performance of the final selected model. And in our project, we use a ratio of 4:1 to divide into training and test sets. Also, we use count function to get the number of training data and test data, and we get the number of trained data is 237 and the number of test set is 52. Finally, we use the show function to show the data set, and we can get the first 3 rows of features in the training data. There are 4 features, and the first 3 rows of labels in training data. the label of the training data is house price, and the first three rows of features in the test data, there are still 6 features. And we also use the count function to count the number of training data set and the test set. And we conclude that the number of training sets is 289 and the number of test sets is 125.
Now I will talk about the part of the tree model. As now we have already processed our data and got the prepared train set and the test set. So we can train 4 different models. For each model, we do the following 4 operations. The first step is to train the model with a training set. And then we can get the root mean square error of the training set and the test set separately. And the third step is to predict the labels of the test set, which is without the labels, with the trained model and output the predictions. And the final step is to write the result to the 4 different files. And the fourth model is a linear regression model. As we can see in this figure, the linear regression attempts to model the relationship between 2 variables by fitting a linear equation to observed data. The equation always has y equals a plus bx, where x is a given feature and y is a predictions. And so we can train the linear regression model. Train the model just import the linear regression package from the specs, and then fit the model and calculate the root mean square error of the train and test data separately. And the third step is to prediction. And finally, we write the result to the file. And the second model is a decision tree model. In this feature, we can see the decision tree model is a model of the computation or communication in which an algorithm or communication process is considered to be a decision tree. And for example, a sequence of the branching operations based on compressions of some quantities, the compressions being assigned the unit computational cost. And for the decision tree model, we do the same 4 steps. First is train the tree model. Just import the decision tree regressor package from the spec, fit the model, calculate the root mean square error, and get the prediction, and then write the result. And next model is a random forest model. And random forest model is an ensemble learning method for classification, regression, and other tests that operates by constructing a multitude of decision trees, and it outputs a class that is model of the classifications. And for the random forest model, after training the model, we can calculate the root mean square error and get the predictions and write the result. This is the same four steps. And finally, we come to the last model. The last model is a gradient boosted train regression. The gradient boosting is a machine learning technique for regression and classification problems, which produce a prediction model in the form of an example of a weak prediction model. And for the last model, we do the same thing, train the gradient boosted tree model and calculate the root mean square error and predict the label of the test set, and finally write the result to the file. As final, we have already trained 4 different models and get 4 different predictions. And so the feature work is about the evaluation and the improvement. Thank you for the listening.